Okay. I think that is everyone let in that's hoping to join us. So good afternoon, everyone. Let me thank you so much for joining us this afternoon. I'm really excited to hear what Sergei has to say. But let me first just introduce myself. My name is Abby. I work with Barry Cranford, who's the founder of the London Java community. I have the privilege of hosting this afternoon's meeting with you all. For those of you who don't know, the London Java community is just one of the communities that's run by RecWorks. We are a tech recruitment company with a difference. As a company, our belief is that recruitment can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. From our perspective, if people want to learn and other people want to teach, we are happy to connect those two groups of people through our communities and events. We see this as a way of giving back to people we've worked with previously, but also being able to pay it forward to those that we hope to work with in the future. We have run over 700 events for developers and engineers within LJC, but also for students, graduates, CTOs. We've run conferences, lightning talks, hackathons, all sorts of things. We've also made over 3,000 introductions between mentors and mentees through our Meet to Mentor program. We love to give opportunities to speakers, whether they are new to speaking or have some experience already, and this event is part of that. If you'd like to know more about any of our communities, please do get in touch and we will take it from there. But with no further ado, let me introduce you to Sergei. He is a senior software engineer at Hazelcast and an active open source contributor. He's always curious and open-minded. He has over 7 years of experience building distributed systems in different domains, so like a healthcare alarming system, networking debugging applications, and so on. He's been a speaker at Java Day Lviv, gconf, Vox Days Minsk, and DevOps Ukraine. And he's here today to speak to us about building fault-tolerant applications with Kubernetes and Istio. There will be an opportunity for a bit of Q&A after Sergei's talk, so do stick around for that. Over to you, Sergei.
Thank you so much for the introduction. So let's start. As already was mentioned, we will be talking about fault-tolerant application today. So let's get started. My name is Sergei. I'm a software engineer at Hazelcast at the Cloud Native team. So let's start talking about fault tolerance. But before starting talking about what is fault tolerance and how to achieve it, I would like to tell a story about one space mission, which was called Mars Climate Orbiter. This mission started in 1998 on 11th of December. It was launched from the Earth, and in 1999 it arrived at Mars. It was supposed to enter the orbit of Mars and study the climate, the atmosphere of Mars. And it was supposed to enter the orbit of Mars at the distance of 226 kilometers. Instead, it entered the atmosphere at the distance of 57 kilometers. It got destroyed and just mission was failed. The reason for this was pretty simple, because two teams which was developing this Mars was this program was using different units of measurement. One team was using English units, another one was using metric units. So this caused this error, which could be avoidable. And when we are talking about fault tolerance, there are three key words that we have to distinguish, which is fault, error, and failure. So first one is fault, which is some defect in the system. This is just in the system. It might not cause anything, but it's there. In case of Mars Climate Orbiter, using different measurement units is a fault. The next one is error, which is something that user can experience, something that client can see. This is the bug that is caused by the fault. So in case of Mars Climate Orbiter, entering the atmosphere of Mars was an error. And the third one is a failure. Failure when the system is broken and it can no longer just work at all. So in case of Mars Climate Orbiter, burning out and destroyed orbiter was definitely a failure. So what does it mean to be a fault tolerant? Does it mean that there shouldn't be any faults, shouldn't be any bugs in the system? Of course not. And a good example of this is another Mars programs. You probably heard of it. This is Spirit and Opportunity. This was 2 rovers that were sent to the Mars to explore just the planet. Both of them was sent in 2003 and was supposed to last on Mars for 19 sols. Sol is like a day, but it's on Mars, so it's slightly longer than Earth's day. First one, Spirit, it arrived on 2004, and instead of lasting for 19 sols, it lasted for 2,210 sols. So it was 5.5 years, which is quite incredible. Opportunity lasted, again, instead of 19 sols, it lasted for more than 5,000 sols, which is 15 years, which is also very incredible. So does it mean that for all of this period they didn't have any problems with anything? Was it designed like perfectly? Of course not. Both rovers had some design flaws. For example, with the back wheels, one of the rover was supposed to move backward, but even though they had these problems, they still lasted and could do their job and found a lot of useful information about the planet. The same with application that we are writing. There will be bugs for sure. In any system, there will be some problems, but users should still be able to use the application, even though there are some problems, but it shouldn't crash. It shouldn't cause the very big problems for users. And today we are going to take a look on how to achieve a fault tolerant using Kubernetes and Istio. Even though this talk is Kubernetes and Istio specific, that's okay if you don't have any experience with it, because it will still be about the concepts and how Kubernetes and Istio can apply these concepts. I won't dig very deep into what Kubernetes and Istio is, but just a quick explanation. So Kubernetes is an orchestration system that will allow you to run your application on some cluster. You shouldn't care about how to do it. Kubernetes will do it for you. It has control plane, and you're just telling what do you want to achieve, and the Kubernetes will make sure that your application is distributed across this cluster. Istio adds its own control plane and also a proxy to each instance of your application, which adds another layer of abstraction, and you can achieve additional things due to this. Okay, so enough talking. Now I think it's time to explore Mars. So what do we need to explore Mars? First of all, we will need a rover, because how do you want to explore Mars another way? Of course, we need rover, and rover needs to talk to ground control. He will get his name and the coordinates of other rovers from ground control, and will send its own coordinates to it. Next, we need some orbiter, which is event orbiter, because Mars is not very friendly environment. So orbiter will warn our rover about some meteors or about underground water. And we also have ground event lander, which will get the data from event orbiter and from the ground control, and will tell us if there are any dust storm or any alien form of life. You might wondering what I'm talking about, because this was supposed to be a talk about Kubernetes Istio, and I'm talking about something how to explore Mars. In fact, this is a game which I have developed. This game will represent our application, and the rover in our case is our browser, and we will get the name and the leaderboard from player service and send the score, which was ground control. And also we have event service and ground event service, which will make our game more enjoyable and playable. And the player service will store the data to Hazelcast cluster as a stateful application that we will have in this example. Okay, so let me show the game. So this is how it looks. As we can see, we have this rover, it can move. And when we are moving, there are meteors that can hit us. And if it hits us, we lose 1 life. Also, we can collect the aliens and we can explore the underground water. There's also dust storm. It could also cause damage. So when we are losing 3 lives, the game is over. So this is our game. What can go wrong? So first of all, let's try to deploy a new version. Let me just make it bigger so everyone can see what I'm typing. Okay, so first of all, let's deploy a new version of event service, because we have a new version, just develop it and let's deploy it. Let's see that it's there. Yeah, so we can see that it's initializing. It will start in a minute, even faster. So let's try to restart our game. So we can see that we are playing and nothing happens. So obviously something is wrong. And now we are starting receiving this events. Let's see our application, our event service. If we take a look at it, okay, just a minute. Okay, so it wasn't that problem that it's supposed to be. Let me play a bit longer so you will see. Yeah, you can see again, we don't receive any events. No meteors. Yeah, so something is definitely wrong. If we take a look at it now, we can see there's 1 restart. Even though it's running, there's 1 restart. So this is something that Kubernetes gives you out of the box. When the application, the microservice crashes, it will automatically restart it. So you will get it again, it working. The problem for now is that there is no other services that can handle the request while this one is crashed. So for this one, we can scale our application to 2, maybe, I don't know, maybe 3 replicas. So we are doing manual scaling. So we can see that for now we have scaled it, and now we have 3 instances of our event service. So if we continue playing the game, we are receiving events, and we should not experience any problems visible to user. But if we take a look at our application, at our instances, we can still see that this one crashed. We can see its error. It restarted 2 times. But even though we have a redundancy, we have achieved a redundancy. So even though it crashed, user does not experience this. Okay, so now this is good because, well, the application crashed. We have fixed the problem, and let's redeploy it and see what happened. Okay, so we can see it's running. Let's continue playing our game. Okay, so I have lost it. So we are continue playing it. Everything seems fine for now. We are exploring Mars. There are meteors. But after some time, we can see that again, there are no meteors, no events like from the event service. But if we take a look at our application, we can see that there are no errors, no restarts of the event service. So something is wrong, but Kubernetes doesn't know about it. This is because application does not always crash when something goes wrong. It could be that it's just it crashed like the application itself, but the process is still running. So Kubernetes doesn't know that something goes wrong. For this, we have to apply health checks so that Kubernetes knows what it should check to see if application is alive and it's healthy. So let me do this. Service. So I have just applied the configuration. And if we take a look at our application now, okay, so it will redeploy it first. Now we can continue playing. For now, everything is okay, as expected. And in minutes, we should experience again the problem with the event service. Yeah, as expected. So no events. If we take a look at the application, we can see that now we have one restart. Again, I have shown just with one instance, just so that it's clear that there are problems. But we have set up the health checks, which is called probes in Kubernetes. And now Kubernetes knows that something went wrong and it has to restart the application. Okay, let's go back to our presentation. And let's recap what we have seen. So first of all is the self-healing mechanism of Kubernetes, which will ensure that when one application, if the pod, the instance of application crashed, it will start the new one. And moreover, it can guarantee that we will have the needed replica, the needed number of replicas in our application. But this is with the manual scaling. And why scaling is important? Let's take a look at some numbers. So for example, if we have one instance of application, which is available 99% of the time, which sounds pretty good, 99%. In fact, it means that our application will experience downtime of 365 days per year. If we just scale this application to 2 instances, we will achieve 99.99% of the time availability and decrease downtime to only 52 minutes per year. And 3 instances will achieve famous 6 nines, and downtime will be decreased to 31 seconds per year, which is pretty nice. Also, Kubernetes have the mechanism of auto-scaling because we cannot always scale in advance. We can do it if we expect some increased number of traffic. For example, if it's like Black Friday or Christmas or I don't know, maybe some football match. But sometimes it's not expected. And in this case, we need to auto-scale. And Kubernetes have mechanisms for this. There are 3 options. First of all is horizontal pod autoscaler, which will increase the number of instances. The next one is vertical pod autoscaler, which will increase the resources for the instance, and cluster autoscaler, which will increase the number of nodes into our cluster. And we have seen the health checks. There are also 3 options. First of all is liveness probe, which we have seen. We can make sure that application is alive. The next one is readiness probe. In this case, Kubernetes won't restart the application. Maybe for some reason it can be slow or not responsible, but we'll get back soon. So if we know that, we can set up readiness probe and startup probe. This is for the application that startup time takes long. So we have to wait, serve traffic only when it's ready. This is how the configuration looks. It's pretty simple. And all the probes are just the same. The only thing is that the keyword is startup probe, readiness probe, and liveness probe. This is all for the ideal world, and by ideal world I mean stateless application. Because in stateless application, each instances are the same. There is no distinguish. You can connect to each instance, and it should be the same. But unfortunately, it's not always the case because we have to store state somewhere. And with the stateful application, if the instance crashes, we cannot just start the new instance and continue like nothing happened, because it is different. Kubernetes also have mechanism for the stateful application. It's a bit tricky because it's not that simple. Each stateful application is different. Like stateless application are the same, but stateful application is different in its state. So Kubernetes allows you to implement the thing for the stateful application by providing some tools. This is stateful set, and it can provide you unique identity. So each instance can be distinguished by its name. It can hold its own state. So for the stateless application, if you want to store the state, it will be shared. For the stateful, it will be for each instance its own. And it will provide the fixed endpoint. So if, for example, you're connected to it and it crashed, you can just reuse the same endpoint to reconnect after it started again. Again, this is just the tools. And for stateful application, you have to implement it by its own. For example, in Hazelcast, we have implemented the Hazelcast Kubernetes plugin, which is merged into the core Hazelcast platform. And with this, we can just run it in the Kubernetes and make sure that it will reconnect and work as expected. Okay, but we have seen some problems that was pretty easy to detect. But again, in the real world, this is not the case. Usually when the problem happens, we don't know where it happens. So for this thing, we need to set up monitoring. And here we have Istio that will help with us. As I've mentioned, on each instance of your application, there is additional Envoy proxy. And this Envoy proxy can collect a lot of data and send it to Istio-D component, which can be integrated with different tracing, metric, logging, and other tools for monitoring. Let's go back to Mars and see what I mean by that. Okay, so. Okay, let me deploy the new version of player service. By its name, you can guess that not everything will be smoothly. So let's continue playing game. So for now, everything works fine as expected. And we can see that the player leaderboard disappeared. So something is wrong. We are continue playing the game. Okay, so it appears again. So we can see that it's blinking. So there is something that is wrong. So we have Grafana. So this is additional add-on which was installed by Istio, but I haven't configured anything by myself. It's like out of the box. So out of the box, we can just go to the dashboards, which are also available. Let's select player service. We know that player service is responsible for leaderboard. And we can see that there are incoming success rate and there is some errors. So it's not 100%, but it's not very low either. So there are some errors, but it's okay. So one thing that we can easily do, again with Istio, we can set up retries. Because for the leaderboard, each request is not like unique. We can afford like sending multiple requests. We can just set up retries using Istio configuration. And even though there is a problem, user will not experience it. Let me apply this. Retry player service. So just applying the configuration. And if we continue playing the game, we should not experience this problem anymore. So as you can see, the leaderboard is not blinking anymore. And if we take a look at the dashboard, again, we can see that there are still errors. So it's not 100%, there are still errors, but user cannot see it. Okay, let me deploy also another version of the event service. So we can continue playing. Okay, so let me Okay, I didn't avoid this one. So we can see that there was some delay with the ground events. So if we are collecting the alien, we are jumping over the storm dust, and there is no ground events. We can see that it's not there. Something is wrong again, and it appears after some time. But again, we don't know what is wrong. So for this one, we have Jaeger. Probably, if someone doesn't know what Jaeger is, this is a distributed tracing tool, the same as Zipkin, just another alternative. Okay, so we know that something is wrong with ground events, right? So we can take a look at it, and we can see that. Okay, we can see that there are some requests that takes up to 10 seconds. So definitely something is wrong. So we can see it. If we take a look at it, we can see that the problem is not in the ground event service itself, but in the event service. Some request to event service takes 10 seconds. Okay, we can go back to Grafana, choose event service, and we can see that, yeah, indeed, there are some real long requests, but it's not all the requests. For example, if we take like percentile of 50, we can see that it's pretty quick, so 15 milliseconds. Okay, so how can we fix this? Again, we can, in this case, with the event service, for us, it could be better, instead of waiting for the long requests, we can just kill it by timeout and send another one, because most probably it will be successful. So we can set up with simple Istio configuration. We can set up this timeout. So again, I have applied the configuration. We are continue playing the game. Okay, oops. So we can see that for now, all the ground events are here, and it appears. It might be some small delay, but for the users, it won't be that noticeable. So yeah, we can see it's there. If we take a look at Jaeger, for example, we can see that the problem is not fixed in the application itself. Okay. So there are some requests that are killed by timeout. We can see because it took too long. We can see that we are waiting for half a second. So in this case, we are just returning an error. And users don't experience it. So there are these requests, but user doesn't know about it, anything. Okay, so let's go back to our application. Not application, sorry, presentation. And let's see what we have just seen. So we've seen resiliency features of Istio, which is retry in case of failed requests and timeout in case of requests that take too long. So this helped us fixing this problem. But there's another solution that could help us fixing this problem, which is caching. So you might expect that I will be talking about Hazelcast, but unfortunately, it's not yet supported by Istio to provide some third-party caching solution. But most probably it will be soon, hopefully soon. But for now, most of us are using a pretty powerful mechanism that has caching, which is HTTP. And I will be talking about the header, which is called cache control. And it provides two options. First option is stale while revalidate. So this is for the requests that takes long, for example, with our event service. We might, instead of waiting for a long running request, we might get the stale result from the cache, while the cache will send asynchronously the request to service. And when the service will respond, it will just update the values in the cache. So this will help us to get the quick response and at the same time update the cache. It might be the stale result from the cache, but still it could be, in some cases, it could be better than waiting for too long. And the second option is stale if error. This is for the case with the leaderboard that we have. So when the client is sending a request to the service and it responds with error, instead of showing the user that something is wrong, we might get the stale result from the cache. So again, from some cases, it could be better. This is how the configuration will look like to set these headers to the response. But with this solution, there is one problem, and this problem is called browser support. As you can see, for stale while revalidate, it's not supported by all the browsers, and for stale if error, it's not supported by most used browsers at all. But hopefully, it will become not experimental, but a stable feature, and then we can just use it to fix this kind of cases. Another thing that can help us is called circuit breaker. This is very important not to think that this circuit breaker is the same as circuit breaker provided by Spring Cloud or Netflix, because it's slightly different concepts. So this can help in case if we have a service and we know how many requests it can handle. For example, we have a service and we know that it can handle 5,000 requests per second. In some case, the number of requests can increase significantly. So instead of 5,000 requests per second, we can get 15,000 requests per second. And the service will just fail, and all the users will experience this failure. Instead, we can set up the circuit breaker with some rules that will say that we can handle 5,000 requests per second. Other 2,000 requests will be waiting for some freed connection, and all the others will be just rejected before getting to the service. So in this case, some users will still experience the errors. Some will experience some delay, but 5,000 requests that we can handle will be served by our service. More advanced thing is rate limit, because if circuit breaker is setting up globally for all the requests, rate limit can be set up for specific user. This is very useful if you are providing some public API and you don't want to be spammed by some bots maybe or something. So in this case, you're setting up some requests limits, and user won't be available to reach above this limit. And moreover, you can set up a different limit for different users. So for example, for simple users, you may set up those, I don't know, 1,000 requests per hour. And if you have a premium users, maybe you can set up the higher limit, maybe 2,000 requests per hour. Okay, but how do we know that everything that we set up, every fault tolerant thing is working? How do we check that our application is in fact fault tolerant? So this is where chaos engineering comes up. It was the methodology popularized by Netflix. Netflix introduced their tool, which is called Chaos Monkey, which was going to production and was killing some instances of application. Now they have the whole army of monkeys, which is called Simian Army. It's just some applications that does some nasty stuff to their production, so they can test that their application really is fault tolerant and really can serve even if something goes wrong. Of course, even though in the production, doing chaos engineering in production is the best chaos engineering, I wouldn't suggest doing it if you're not already doing chaos engineering. So we have to start with the small steps. And the small steps can provide Istio with the mechanism called fault injection. So we can just emulate something which goes wrong by injecting some errors or some delays to emulate some latency, slow internet connection, or something like this. And let's take a look on how this works. But before we are going to take a look at it, I have this link for you. you can scan the QR code and try to play the game while I will do some chaos engineering, because it's the best to do in production, so that's what we are going to do. I will wait for a few minutes, for maybe 1 minute, so you can scan the application and join it. Okay, so hopefully you have joined. If you didn't, then you can always see this link in browser above, so you can start it and try to play it. It's Explorer Istio demo XYZ. Okay, so you can play the game. I will show you because I have developed it for the mobile as well. And as you can see, I'm not a UI developer because these aren't the most beautiful buttons, but they are functional. So you can move forward, backward, jump, and you can scan for underground water. So collecting aliens and scanning for water will give you points. Moving also will give you points. Okay, so now while you are playing the game, I can see that everything goes well. I will just apply some configuration by Istio. For example, a board player. It will emulate the problem that we had with the leaderboard previously. So it's just a configuration without needing to deploy anything. We can start playing it and we can see that there are some problems. Just in a minute. Okay, so we can see that leaderboard is blinking as we had previously, but this is just with the Istio configuration. So we can just test how our application will behave, and we will know what will user experience before user can experience this. The next thing is event service. So delay event, as you may guess, it will insert some delays into the application. And if we continue playing, we can see that there is no meteors coming. So events are simply slow. It should come in a while. We are experiencing. So in this case, we can emulate how it will behave for our users. Okay, let me clean this up. Okay, so now it's working fine. All right, so let me restart the game. I can see that on the first place is the matter of Virgin Galactic. So whoever is playing for the Demeter Virgin Galactic, please contact me or the organizers, so they will pass me your contacts, because I have a gift for you as you're the best player today. And we will continue with our presentation meanwhile. So we have seen different things how to achieve fault tolerance. But in fact, I have talked with some people about my game, and we come to conclusion that it's not very realistic. For example, meteors doesn't behave in this way. So for this reason, I have applied the changes to my application, and I want to release this. Yep. So I am applying these changes. I'm using the mechanism called rolling updates of Kubernetes. So we can see that it's applying. We can start, continue playing our game. So these are still the old meteors. This is not the ones that we are interested in. In a while, we will start experiencing the real meteors, how they behave in real life. Okay, so yeah, that's the meteors, how they behave in real life. Much better, right? Of course not, because now the game is unplayable. So let me go back to my application, to my presentation. So we have seen the rolling updates of Kubernetes. So there are two news. So rolling updates, first of all, allows you to deploy the new version without downtime by starting the new version one by one. And the good news is that we can roll it back in the same way easily. But we have the bad news that everyone who was playing the game, all the users, experienced it, and probably they hate me now. So yeah, this is the problem. Let me, okay, sorry. The more safer way to release it would be canary release. This will still allow us to have feedback from real users, but instead of exposing the new version to all the users, we can expose it to a small percentage of users, for example, 1% of users, or maybe to some specific users, maybe the users who are using mobile browsers, or maybe the users who are using Safari, Google Chrome, or something. And in the worst case scenario, we'll lose only this small percentage of user, but it will still allow us to have the real feedback from the users, because as we know, all the bad things happen in production, not on the staging environment. Okay, so first of all, let me undo the deployment of my application. So let me show you that it is starting the new version the old version is rolling back one by one. So again, it's without any downtime, which allows us to like deploy the new or to roll back the older version without experiencing downtime. Okay, so now we are with our old version of application. So yeah, the playable one. And let's try to do the canary deployment. So first of all, I will need to deploy the second version. So I am deploying the second version of application. It will be deployed in a while. Just a minute. It shouldn't be very. Yeah, it's already started. So if we are playing the game, for now we will see that sometimes we are seeing the old meteors, the slow one, and sometimes the fast one. This is because we now have two versions of application, and we are just getting load balanced between these two versions. But we don't want all the users to experience this this new version. So for that, we will apply some configuration, which will expose only some specific rovers, the rovers from specific company. In this case, I am playing for Bigelow Aerospace. And let's apply this configuration to make them our test users. Okay, so this is configuration. Of course, it's YAML. Hopefully I typed it correctly. Yeah, probably. Okay. So by applying this configuration, now, as I'm playing for Bigelow Aerospace, you can see that I'm seeing only the new meteors. If I restart the game, now I'm playing for Blue Origin. And as Blue Origin, I only see the old meteors. So in this case, only the specific rovers will be our canary users, which will be testing our application and will give us real feedback. Okay, so let's go back to our presentation. So we have seen how to apply the fault tolerance using our infrastructure layer, which is Kubernetes, Istio. This is not our application layer, this is infrastructure. Should this be enough? Should we don't care about our code to make it fault tolerance and just rely to infrastructure? Of course not, because fault tolerance should be applied everywhere. Even in case of my application, I still have some fault tolerant features. Otherwise, the application might not be playable at all. For example, in case of error, I don't crash the whole Usually I don't crash the whole UI, so the player can still use, instead of just crashing it, I'm don't showing leaderboard or something, or just when receiving errors from event service, I don't crash it, I just send it again. So these were some examples of the fault tolerance features that I have applied in the code. How to do it? I can suggest two things. First of all is nice talk from Nikita Protsenko and Alex Borisov. These are two great engineers that works at Netflix. And this talk actually was inspiration from my talk. And they are showing how to achieve fault tolerance in the code with the technologies such as gRPC and REST. And the next thing I can suggest a book called Patterns for Fault Tolerant Software by Robert Hanmer. This book is old, but this is not book that focus on technologies. It's focused on patterns, so it will always be actual. So this is also a nice book that I can suggest. Here is the link for my demo. If you're interested in it, if you want to try some Istio and Kubernetes configuration, or maybe you just liked my game, I hope you do, then you can try to play with it and maybe try to learn it a bit more. So for me, that's all. Thank you very much for your attention. And if you have any questions, I will be glad to answer them.
Thank you so much, Sergii. That was great. I did really terribly at your game, so it definitely won't be me that won it.
As you can see, I'm also bad at that game. So,
does anybody have any questions for Sergii? Feel free to unmute yourselves and ask anything you want to know.
Hi, Sergei. I've got one question. My name's Nitin. For the circuit breaker part, obviously you could set the limits. Was that limits for the service level or at the actual pod level, where you can say like 5,000 requests per second?
So this is for the, I would say it's called in the Istio workload, but this is for the service. So you have to know like how many requests will handle your service, having how many instances you have.
Okay, yeah, because I was just wondering like if you could figure out like if you do performance testing, you know, one service could handle 1,000. And if it could be specific to each one, then that will make more sense. But yeah, if it's at a service level, then someone has to do the calculation to work that out, depending on how many instances you have running.
Yeah, correct. Yeah.
Okay, great. Thank you.
Anybody else got any questions?
I don't have a question, but I just wanted to say thank you for the presentation.
Yeah, thank you. Thank you for the feedback.
We have been asked, Sergii, if you can put the links in the chat, just so that people can get access to them that way, if that's possible.
Which links? Sorry.
That's from Victor. Victor, which links are you particularly after?
I believe that could be the links, this one with the demo.
I would guess possibly so, yes.
Yeah, sure. Let me.
Yeah,
just
from the end of the presentation,
right
he said. Yeah, so that one, please,
okay.
If you would put that in the chat, that would be brilliant. Then everyone can get it. Perfect. Nito has asked, if you were starting with Istio now, what are the best resources for learning?
There is. They have, first of all, they have very great documentation with just an examples of different scenarios. For example, if you want to set up circuit breaker, if you want to set up limits or something, they have very nice documentation. Also, there is a resource called Learn Istio. It's I could not remember correct website where it was where it's hosting because it was moved, I believe. But if you try to search for Learn Istio, it will be there. But the main thing that I would suggest is to try to learn about Envoy, because Envoy is the proxy that is used by Istio. And in fact, this is the heart of Istio. Istio is just an abstraction of all the features that Envoy have. So it's like a convenient way of using Envoy. So if I remember correctly, the best resource for learning Envoy is called Get Envoy. So there are a lot of also examples and tutorials how to use it. So I would say these are 3 best things that could help you start for sure. But if you want just to start quickly, start with the documentation with their examples. This should be enough to quickly start and have some basic scenarios set up.
Fantastic, thank you. Any more questions from anybody?
Yeah, I've just got sorry, one more question. Again, regarding the circuit breakers. Obviously, once it starts throttling, it will queue it. Do you know if there's any kind of a metrics from Istio that will say it's queuing it? Because I'm just thinking, as in a HPA point of view, like if you start queuing, then it can start reacting on that while all the requests are queued up. Otherwise,
yeah,
if
so
requests are coming in, then yeah, it will should still show it at a kind of service level.
So yeah, the Istio, as I showed, it already collects a lot of metrics, and it can be integrated easily with different tools. With Prometheus, for example, with Prometheus, it's super easy. For example, Grafana, which I was using, was querying the Prometheus dashboard. And there are already a lot of metrics that you get out of the box with the number of requests for workload for specific pod, and it's pretty easy to set up to query it, like just using Prometheus. You can, of course, integrate it with any other tools because Istio is easily integratable. But out of the box, it comes with Prometheus, which you can just install and have it out of the box. So yeah, you can definitely do it.
Okay, thanks.
Any other questions, burning questions anyone wants to ask before we close? Okay, lovely. Well, all that leaves for me to do now is to say thank you so much, Sergii, for sharing that with us. That was really interesting. Yeah, I'm terrible at your game, but that's fine. I still enjoyed it. So yeah, thank you so much. And the recording of this talk will be on our YouTube channel shortly as well. So anyone who didn't get to get here will be able to catch it that way, or you can watch again at another time. Thanks so much for joining us, guys. Have a great afternoon.
Yeah, thank you, everyone. And I want to add that if you have any question after that, you can just contact me in Twitter. And also I will post the presentation to the Twitter. So all the links that were in the slides, because there were some links related to the articles, which I referred to when I prepared the talk, you can also find there. So thank you very much, everyone.
Fantastic.
And don't forget the winner to contact me or the organizers, because I have a present.
Will do. Fantastic. Thank you so much. Have a good afternoon.
Thank you. Bye-bye, everyone.
Bye.